Geometry. Unit 1, Lesson 14 is called Defining Rotations. So our goals today are: I can describe a rotation by stating the center and the angle of rotation and direction, and I can draw rotations. Okay, so pause the video and go ahead and give the warm-up a try here. It says for each figure, which pair of angles appears congruent? How could you check? So an easy way to check is with tracing paper. So if you have any tracing paper, maybe your teacher has some, you can get some and take it home, or you can order it online if you just Google tracing paper. This is a little bit easier than using a protractor. I can just take my angle, trace it, and you can kind of line it up, and you can see here clearly angle CBA is not congruent to angle DEF. But over here, they're congruent. You can tell that they match up. So for here, angle, and I'm going to use the notation instead of circling them, angle CBA is congruent to angle LHG. Okay, over here, I think these two look a little bit bigger than angle YZM. So I trace them, and let's check, and there they are. Okay, if I want to double check with this one here, just line up a side, and you can tell they're not congruent. It's definitely, this angle is smaller than the other two. So over here, I would say angle LSR is congruent to angle KBP. Okay, as long as, and you can name these two different ways. Actually, you can name them three different ways. You can name it angle RSL or angle PBK, or you could just name it angle S or angle B because there's only one angle at that point. Okay, over here you can tell that the two smaller ones are congruent. So there's that. You can tell that they're the same. So over here, I'm just going to use one letter here. I'm going to say angle V is congruent to angle J. I can use one letter if there's only one angle there. Okay. And over here, not really sure. Kind of hard to tell. Kind of small. I should have made this a little bit bigger. But at first glance, I would say this angle CBA, is pretty big. It looks obtuse. And these other two look acute. So maybe, yeah, let me start over. I missed the line there. GHL looks like it's congruent here to right there, that angle right there. So many different ways to name this. You just need a point on this ray or on this segment, I guess. So I'll just say angle LHG is congruent to angle DEF. Okay. All right. So rotations here. I have this website called GeoGebra. It's actually a free website. You can Google it, and you can play around with it. It's really kind of a useful site, but it does a little bit better job at rotations. The program that I use called Smart Notebook, it doesn't let me distinguish a center of rotation, so it makes it a little bit harder to show. So I'm going to just draw a figure here, and I'm going to rotate it. So let's see here. Let me draw polygon. So I'll make it really distinct. I'll make it kind of like a weird shape, so I think you can see it a little bit better. Now it names the vertices in capital letters and the sides in lowercase. So it looks kind of like a lot there, but they call this side E. Okay, and then this is point A, point E, side lowercase d, point capital D, and so forth. But let me get a point here. So this will be my point that I'm going to rotate F here. Hang on, let me get it again. There we go. So let's do this. Let's rotate it 90 degrees clockwise. So I'm going to go down to rotate around point, and I have to select the object. Hang on here. And my point of rotation. So I'm going to go 90 degrees, and I'm going to go clockwise. And there it is. Okay, so what really happens here is this is my center of rotation, 90 degrees clockwise. So I'm going to pick 2 points that correspond. Okay, so I'll just use D and D prime because they're the closest. So I'm just going to draw a segment from D to D prime, if I can get my thing to work. There we go. Well, I wanted to be in blue, but it didn't come out. But if you look here, this is a 90-degree angle, right? And really what's going to happen is every point, if I go from the original or the pre-image, like E, to the image E, they're all going to form right angles. And what's even cooler here is they're the same distance. So let me find my compass button here, compass. So if I look there, oh, hold on. Having problems here with this because of this right there and this. So there we go. There we go. So this point D is going to swing over here to D prime. And if I make an angle with D prime to F to D, this is going to form a right angle. Okay. And it's going to happen with every point. Like, let's look at E. So E to E prime. All right. If I were to make an angle E to F to E prime here, it will form a right angle, and he swings out 90 degrees. Same thing with D. So I can make circles for all of these here, and the points would basically kind of, more or less, if this is my point here, it would rotate along that arc 90 degrees, okay? All right, so this is one of those info gaps. So they give us this picture and they tell us some info, but they don't tell us the data. So we're gonna have to ask questions to find out the data. So it says triangle DCI. So I'm gonna draw DCI here. Triangle DCI has been rotated so that the vertices of its image are labeled points. What is the image? Okay, so if we were doing this in class, I would start asking questions, okay? So this is my pre-image, because this is being rotated. So I would start asking, do I have the image of D? Do I have the image of C? Do I have the image of I? Do I have the center of rotation? Do I know the angle of rotation? Do I know the direction? Okay, I'd start asking all those things, okay? So this is the pre-image. We want to find the image. So I'd ask all those questions, and let's see what we get here. So the angle of rotation is HLI. So let's draw this here, HLI. So that makes me think that we're going this way here. Just because it looks like I will swing out to H. They look like they're the same distance. Okay, but then I look at the second one, it says, oh, the rotation is counterclockwise. Oh, okay, so that makes sense. Center of rotation looks like L, which it is here, okay? And then they start giving us images. So the image of C is G. I'll just start highlighting these. This image of C is G. I'll use the same color here so you can kind of see it. The image of I is H, kind of what I suspected. Image of L is L. I don't really care about L because L is not really a triangle. The image of U is C. Again, I don't really care about that. The image of V is D. I need the image of D. I need the image of D. It's probably going to be B over here because as I look here, it's the only one that would form the same triangle. But what I could do is I could kind of just trace this angle here and turn it so that it goes to D. Okay, that looks pretty good. And this looks like it's going to go to B. Obviously, it's a little off because I didn't use perfectly straight lines, but you can kind of see it there. So that makes me think here that this is my new triangle, HBG. Now, I need to make sure I write it in the same order. So D corresponds to B. Let me use a different color here. So there's my D and there's my B. So I got to write them in order. So D corresponds to B, C corresponds to G, and H corresponds to I. So I would say triangle BGH. Okay? Next one. Several points have been rotated around a label point. Precisely describe the rotation. Okay, let me erase all of this. All right, so I would start asking questions. Do I have the point that you're rotating around? Which points are being rotated? Do I know the image? Do I know the pre-image of certain points? All those kinds of things are good questions to ask. So the angle of rotation they give us, and they give us the center. Center is N. So N is right here. So this is my center. My angle of rotation is HNW. So HNW. They don't tell us the direction. We don't know if W goes to H or H goes to N. We know the image of F is H. So I'm going to do my pre-image. How about this? I'll use my pre-image in purple. So the image of F. So pre-image are these ones. So I'm going to make them purple since purple starts with P and so does pre-image. H is right here. J is right here. And N is right here. So this is my figure. Let's see how that comes out. A little off. Let me try it again. Try it one more time. I have this tool that it'll straighten it out a little bit better. Not quite. I'm just gonna freehand it. Or you know what, I'm gonna just use the all right, so there's my original. And then I'll do the image in, I don't know, red, I guess. So the image of F is H. The image of W, or image of H is W. Image of J is B. And the image of N is N. So this is gonna look something like that, okay? So I have to describe it. So rotate F H J N. Now I labeled that wrong because here's J, you can't see it, but F H J N. I have to go in order, so it's going to be F H N J. I have to go. I can't zig and zag. I have to name them all the way around it. So F H N J. So we're going to go clockwise around point N. N is my center. an angle of H and W. Okay, that's your angle of rotation. So you need a center, so point N, you need an image, and we need a direction, and we need an angle of rotation. And I could even say to get, I'm going to stay in order here. So the image of F is H, image of H is W, N is N, and then J is B. Okay. Now this last part is kind of optional, but there it is. Okay. All right. Draw a segment, label the endpoints A and B. Rotate AB clockwise around center B by 90 degrees. Okay, I'm going to just draw a segment right here. Here's A and B. Okay, rotate segment AB clockwise around center B by 90 degrees. So basically B stays fixed. It's kind of like, think of your circle here. It's kind of like I take this point A, swing it 90 degrees up here. So this would be my A prime. And here is my new figure, okay? Use the polygon tool to draw a triangle A, B, A prime. Well, I'm just gonna sketch it right there, okay? What kind of triangle did you draw? What other properties do you notice? So I would say that this is a right triangle. Why? Because we know that's 90 degrees. I would say it's isosceles because these are both radii on a circle and those are congruent. I guess if you really want to get fancy, and this isn't something that we've learned yet, you could say that since it's isosceles, these angles will be the same. You could say it's a 45, 45, 90 right triangle, okay? But this one I wouldn't expect you to know right now, okay? Draw a segment and label the endpoints C and D. All right, here's my segment, C, D. Rotate segment CD counterclockwise around D by 30 degrees. So here's my center. This point stays fixed. 30-degree angle is right about here. Here's 90, so it's almost like I take my 90 and I cut it into thirds. I should probably use a protractor here. So 30 degrees would be like right here. Now I have to make sure that I'm the same length. I kind of drew it kind of ballparked it, which actually ended up working out pretty good because it is the same length. Okay, so I rotated 30 degrees counterclockwise, so it swung right here like that by 30 degrees, centered right here at D. Label the new point C prime. Okay. Rotate segment C prime D counterclockwise, center D by 30 degrees. Okay, so let's move this back here. "30 degrees would be right there, and I keep the same length. Okay, so here we go again. So I'm going to label this C double prime. So draw triangle C, D, C double prime. So I'll just do it here in green. C, D, C double prime. So it'd be like that triangle, okay? What kind of triangle did you draw? Well, I think it looks like an equilateral triangle. I know that these two sides are congruent for sure because they're radii. I have a strong hunch that that is congruent as well. Now, if these are 30 degrees here, this is 60, okay? Then these are both going to be 62 because it's isosceles. So technically it is definitely equilateral. So I would say equilateral, okay? So I would say CD is congruent to DC double prime because they're radii on the same circle. And then C prime, or C double prime, is congruent to it also because this angle here is 30 plus 30, 60. And then these are congruent because it's isosceles. So because all of these are 60s, we know that it's an equilateral because equilaterals always have all three angles as 60 degrees. All right, so just a quick review of a definition of rotation. Rotation is a rigid transformation. Okay, one of three rigid transformations. You got rotation, reflection, and translation. It takes a point to another point on the circle through the original point with the given center. The two radii to the original point and the image make a given angle. So P to B, P prime. So again, think of it like it's traveling on a circle. A lot of times there's no circle actually there, but if I were to draw a circle, you can very easily see that P would rotate on the circle. This angle here, A, equidistant from there. In this case, we're rotating counterclockwise, okay? All right, last thing here. Andre tried to rotate triangle ABC 45 degrees counterclockwise. He knows something went wrong because the image doesn't seem to be congruent to the original figure. What is one idea Andre probably understands about rotations? What's one idea that Andre doesn't understand about rotations? Rotate triangle ABC by 45 degrees counterclockwise, avoiding Andre's mistake. So, let's see here. Here's his original. So he draws A to A prime. I'm assuming he measured that at 45 degrees and it stays on the same circle. That looks pretty good. Here's B to B prime. Assuming that's the same dimension. And then C to C prime. Definitely got bigger. So I guess where is his mistake? I'm not seeing it. Are the angles the same? Let's check the angles here. They look the same at first. Yeah, they look like they're the same. So A to A prime, B to B prime, C to C prime. Oh, I see the problem. He used a different center here every time. He went from D, center D, and then he did center E, and then he went to center F. So he's using different centers every time. So he understands the angle measure. He understands that you have to go on a circle. The point has to move on a circle for your angle, but he does not understand that you need to keep the same center. Okay. So, back to this one, I would just maybe fix it right here by just drawing the B to D. Make sure you go to the same point, and then draw your angle here. So that's going to adjust your B a little bit. Make sure you measure your 45-degree angle. I'm not going to do it for the sake of time. And then same thing here for my C. Make sure you go to D here. And again, measure your 45-degree angle. If you want to put a circle here, so you see where to move the point. That would help too. But there you go. All right. So anyways, last thing here, here's one more definition of a rotation. If you need some extra definitions for your notes, feel free to pause the video and jot this down. So, well, thanks for watching this video, and we'll see you next time.